Hello, welcome back. So today we're going to be doing a power calculation example. So after reading this, we can go ahead and start this example. So the idea is that we have some engineer, and the engineer wants to prove that the sum of these values, we know that some of them are going to be absorbed, and some are going to be generated. So the idea is that the absorbed plus the generated sums to 0. If this is true, then we are going to be correct. If not, we're going to be false. All right? Let's go ahead and get started. So, analyzing this piece of information right here. Let's only look at this piece. So, I see that I have my voltage drop A, B, C. My D is right here. E, F, G, and H. All right? In this case, we are going to figure out what the voltage drops are, or voltage rises, and we're going to figure out whether or not the power, which is our voltage times our current, is going to either be absorbing or being generated. All right? So let's go ahead and start with A. So we're going to look at the power for A. Now, when I'm looking at A, I see that my current is already defined. Now, this textbook has already shown that this is the polarity for this element. Now, because it's arbitrary, we can just roll with it, all right? So IA is going from our negative terminal towards our positive terminal, so we're going to call this a voltage rise. Now, due to passive sign convention, when we have a voltage rise, we're going to write our power as negative VI for this element specifically, all right? So let's go ahead and do that. Our power for A is going to be negative our voltage value times our current value. Let's write it for B. Our power for B is going to be this piece right here. Now it's going from our positive terminal towards our negative terminal. And what I'm saying, it is going, the current IB is flowing from the positive terminal towards the negative terminal. Now, this is going to be our voltage drop. So we have positive V times I. Our power for C, our current IC goes from our positive terminal towards our negative terminal. So obeying passive sign convention, we're going to end up with a positive V times I. Our power D is going to be right here. Now I see my current ID is in the direction from negative towards positive. So again, obeying passive sign convention, this is going to be negative V times I. Now, power for E. My power for E, I have my positive terminal and my negative terminal. My current IE flows from my positive terminal towards my negative terminal. Again, obeying passive sign convention, I'm going to have positive V times I. Continuing down, I'm going to have my power F. My power F is going to be going in the direction of a voltage drop. So I'm going to have my positive V times I. Now, my power G. Power G, I see, is going to be from my positive terminal towards my negative. Again, obeying passive sign convention is going to be positive VI. And lastly, let's do power H right here. My power for H is going to be in the direction of a voltage rise. I'm going from my negative terminal towards my positive terminal. So, obeying that, I have my negative V times I. So let's go ahead and substitute our values in, knowing that we've obeyed passive sign convention. All right, so let's make a little note for ourselves to keep progress. So here, in step 1, we've wrote power with respect to passive sign convention. All right, that's step 1. Now, step 2, we are going to sub values. And of course, these values are going to come from our table right over here. All right? So, seeing for power A, on power A, we have 46, a negative because of our passive sign, negative 46.16 times our 6.0. And keep in mind that these are going to be volts and amps, so no need to modify. My power for B, I'm going to have a positive 14.16 multiplied with a 4.72. My power for C is going to be negative 32 multiplied with my negative 6.4. Now, my power for D, I have my negative that comes from the passive sign convention, and then now my V is going to be 22 multiplied with my I value, which is 1.28. My E, I have a positive. My power for E becomes negative 33.6 times a, negative 1.68. My power for F, I have a positive 66 times 0.4, and my G, I'm going to have a positive 2.56 multiplied with a 1.28. And lastly, my H, I have the negative coming from my passive sign convention, don't forget that. My V value is going to be negative 0.4, and my I value is going to be 0.4. Now, what's super important is that I recognize that, hey, I'm including the negatives that come from the passive sign conventions. I'm including the positives that come from passive sign convention. Now, it might be a little bit tedious to do, but in this case, for example, power for C, I see that I have two negative values. So it's super important that I'm adding them in there, and these are not from passive sign convention. These just come from the polarity that we're describing. So let's go ahead and calculate it. Let's go ahead and add a new page. So for power A, I'm going to be getting, let's see, my value for power A will be negative 276.96 watt. Power B will equal to 66.8352 watts. My power for C will equal to 204.8 watt. My power for D will equal to negative 28.16 watt. My power for E will equal to 56.448 watt. My power F will equal to 26.4 watt. And my power for G will equal to 3.2768 watt. And lastly, my power for H will equal to negative 160 times 10 to the negative 3, which is exactly 0.16 watt. Negative. All right, so what do all these values mean? This is just a bunch of nonsense because I haven't interpreted it yet. So let's take an extra step and let's call this step 3. Absorbing or generating? So let's go ahead and ask ourselves this. If it's absorbing, it gets an A. If it's generating, it gets a G. So in this case, I have a negative value for A. So I'm going to say this guy is going to be generating. Let's do that in a different color. This guy is going to be generating. In power B, I have a positive value. It's going to be absorbing. Positive value, absorbing. Negative value, generating. Positive value, absorbing. positive value absorbing, positive value absorbing, and negative value generating. Now, what can we do with this information? We're going to go on step 4. We're going to sum all our absorbing elements plus our generating elements. Now, this means that I'm going to literally take all of these values and sum them. So, upon doing that, I get 52.48 watts. Now, what does this look like? Well, it looks like this guy, this subordinate engineer, is correct. They are absolutely correct. There is the power that is generated and the power that is absorbed. So generated plus the power absorbed does not equal 0. This is why the subordinate engine is correct. Now, how can we fix this? We need to have an equal amount of power being absorbed and an equal amount of power being generated. Now, if this is not true, we will never conserve power. It'll never be 0. All right? So, this was example 1.31.